tutorial is intended for Bank 2, and I'm going to take you through MA 210 Engineering Mathematics 1 Introduction. So you have to understand that there are mainly three topics in MA 210, and that is calculus. Then from there you go to trig, and then from there you go to matrices. That ends the course. That is MA 210. Okay. Now because of time, we are only going to do introduction to differential calculus. You have to understand that there are two types of calculus. We have integral calculus as well as what? Differential calculus. So I'm just going to take you through differential calculus, just an introductory part. Now, before you delve so much into differential calculus, you have to understand that differential calculus requires some basic knowledge. And that is, one, you need functions. Okay, so the idea of the functions that you learned, I don't know if it's in grade 8, 9, 10, 11, 12, you learned those things. Then 2, you need an idea of a limit. 3, you need an idea of coordinate geometry. But under coordinate geometry, the only thing important to us is the gradient of a straight line. Okay, gradient of a straight line. Gradient of a straight line, and the gradient of a curve. Okay, then from there you need algebra. No matter what you do, you can't run away from it. You need algebra. So what I'm going to do, I'm going to introduce functions. Then from functions, I'll introduce the idea of a limit. Then from the idea of a limit, I'll introduce coordinate geometry, that is the gradient of a straight line, and the gradient of the curve. The algebra is just part of everything here. Okay, so for functions, start with functions. I do not know what you are told what a function is, but one thing you have to understand is many instructors, they say a function can be defined as a rule. A function can also be defined as a mathematical expression that relates one thing to another, or it can also be defined as a machine. Okay, but before I define what a function is, I'm going to describe it and dissect it into parts. Okay, so if I write something like f of x is equal to 3x plus 5, okay, so this expression that I've written here, for lack of better term, it has two parts. Okay, so this part here and that other part. Okay, so this part here, I'm going to call it the input side. Okay, then this part here, I'm going to call it the output side. Okay, so now one thing you have to understand is, yes, I'm writing f of x is equal to 3x plus 5, but this x here, I'm not going to be calling it x, I'm going to call it the input. Okay, sometimes I can say x, but deep down you need to know that from now on we shall be calling it the input. Okay, so whatever is in the brackets here, it is what? Our input. Okay, then this side here on the output side, we shall find a rule. Okay, a rule which is simply a manipulation of the input. Okay, so if I say f of a is equal to, it means that here my input is what? Is a. Okay, a is my input. Okay, then on the output side, I'm going to find a rule which manipulates the what? The input, so that I have my output. And what is the rule? If I write, it is what? If I say 3a plus 5, I'm saying I'm going to multiply my input by 3, then add 5 to the result. I'll have my output. So whenever you are given a function, please identify the what? The rule. Once you identify the rule, also identify the input. Then the rule will tell you what you have to do to the what? To the input. Okay? Let's have an example. If I say f of x is equal to 6x plus 7, okay? Then what I know is my input here is x, okay? Then the rule here is whatever you whatever input you have, multiply it by 6, then add what? 7, okay? Then from there, if you are taught to find f of 2, this means that my input is what? It's not x now, but my input is what? 2. So that is f of 2 is equal to, the rule is saying multiply the input by 2, that is input by 2, then add what? 7. Here I'm getting 12 plus 7, I'm getting 19. So that my output is 19. If I have my input as 2, my output is what? 19. Okay? So now we talk about the general case. If I'm given f of x is equal to x plus 5, and I'm told to find f of a. Here I'm given the general input. My input here is what? X. Okay? And this f of x doesn't mean that f times x. Just see the notation for what is the output when the input is x. Okay? So here, my rule is to the input add a 5. Okay? So my input is a. So here, according to the rule, is saying to the input, just add a 5. So if you have f of x is equal to x plus 5, the answer is f of a is equal to what? A plus 5. I hope there's no problem there. Okay? Now, sometimes you won't be told to find f of a or f of x. What you'll be told, they can give you a function. Say, given a function, f of x is equal to 3x plus 6. Simplify. Okay? Simplify. If I say simplify, a f of x plus h minus f of x over h. Okay? One thing you have to understand is, in calculus, this here is known as a quotient difference. Okay, so sometimes I might be using the word quotient difference. Just know that I'm talking about this whole thing, f of x plus h minus f of x over what? Over h. Okay? Now, before I write everything, I'm going to separate this. When I say f of x is equal to 3x plus 6, it means that my input is what? X. Okay? Then the output will be found by multiplying the input by 3 and adding a 6. Okay? So if I say I want to find f of x plus h, it means that my input is not x now. My input is what? X plus h. Okay? The rule does not change. The rule remains the same. Multiply the input by 3, then add a 6. Now, because this input is a two-termed expression, I have to put it in brackets. So I'm going to say 3 times my input, which is x plus h, plus, then add a 6. That's what the rule is saying. So that here I'm going to get 3 open bracket x plus h plus 6. Okay? Then if I say I want to simplify now this, I'll say f of x plus h minus f of x over h. I know the rule. The rule given in the question is f of x is equal to 3x plus 6. Okay? So if my input is x plus h, then I know that on this part, I'm going to say my input is x plus h. The rule is multiply the input by 3. Okay? Then add a 6. Okay? Then I'm going to say minus f of x. But I know that f of x is what? 3x plus h, because here it is saying my input is x. So I'm going to multiply my input by 3, then add a 6. Okay? Now, because this is a two-termed expression, I have to include brackets. So I will open, then I'll say 3x plus what? Plus 6 over h. Okay? Now, here what remains is the algebra part. Okay? As I was saying, it's just part of that. So it's the algebra part. I'll just distribute that. Then I'll say this is 3x plus 3h plus 6 here. This negative times that is negative 3x. Negative times that is negative 6 over h. So here I know, like terms together, this 3x can go with that negative 3x, so that we have, then this 6 can go with that negative 6, so that we have 3h over h. Okay, here we can cancel. That is h over h. So long as h not equal to 0, we can cancel now, so that we have what? A 3. So instead of saying f of x plus h minus f of x over h, when you are given the rule f of x is equal to 3x plus 6, you can just say 3. Okay, so we've simplified that function. I hope there's no problem there. So that's just an introduction on the idea of a function. So we go to the idea of a limit. Okay. Because of time, I'm not going to go into technical details of a limit. There must be a technical definition, okay? And I hope that if we have time together, I'm going to explain it to you. I'll give it to you, and then from there we shall proceed. But here I'll just give you a crude idea of what a limit is, okay? So, a limit is simply a number to which a particular function approaches when the independent variable in the expression approaches a particular number. For example, if I say 3x plus 5, okay? What is the value that this function, this expression 3x plus 5 will approach when x approaches what? 2. That's the idea of a limit, okay? So sometimes you might just be given the notation telling you to evaluate it. So if I say lim x approaches 2, 3x plus 5. Here I'm told to find the limiting value of this function, 3x plus 5, when x approaches 2. Okay, so that is how you read this. Find the limiting value of 3x plus 5 as x approaches 2. Okay, and take note, this is not an equal sign, it's an arrow. X approaches 2. Okay, so if I write lim x approaches 2, what you have to understand is I write 3x plus 5. I'll just give a simple rule because of time. Just get the 2 here, plug it in, then find the answer. Take this as your input, okay? So here it means my input is 2, so I'll say 3 times 2 plus what? Plus 5. I'm getting what? This is 6 plus 5, you get 11. So that you can write this as the limiting value of 3x plus 5 as x approaches 2 is equal to 11, okay? I hope there's no problem there. If I write, take the limiting value x approaches 2 of x squared minus 3. Okay? So from here we know that we can just do a direct substitution. We just get the 2, plug it where there is an x there. So I'll write, this is 2 squared minus 3. Okay? Is equal to 4 minus 3. We get a 1. Okay? And note that these are not the only things that we do under limits. There are a lot of things, there are a lot of rules and laws that you can use. For example, El Hospital's rule to evaluate a limit, but here is just an introductory part that will help us understand introduction to differential calculus. Okay? So here I'll write it as the limiting value of x squared minus 3 as x approaches 2 is equal to 1. Okay? Now, there are some times when you won't be given a direct linear function or a quadratic function, but something like this. Lim x approaches 3 of x squared minus 9 over x minus 3. Okay? So here we have a problem. If we apply the rule of direct substitution there, we shall have something like this. Okay? We shall have something like this. We say x squared minus 9 over x minus 3, lim x approaches 3, we're going to have 3 squared minus 9 over 3 minus 3, okay? And this becomes 0 over 0, and we might be tempted to say that the answer is 0, or I don't know, but we know that this is undefined. By saying undefined, yes, the answer might be there, but only Jesus knows the answer. So from now on, just know that a case like this, only Jesus knows the what? The answer. Okay? So, in technical terms, we say this is an indeterminate form, or it's a taboo to evaluate such an answer. 0 divided by 0, just know that it's undefined or infinity. Okay? So, how do we go about that? Then, algebra comes into play. Okay? This is x squared minus 9 over x minus 3. I know from elementary mathematics that we've been told that this here is a difference of 2 squares. Okay? Difference of 2 squares. So that we can write lim x approaches 3. We can write this as x squared minus 3 squared over x minus 3. Okay? Now, take note that I'm taking the lim as well as the x approaches 3 all the way because I haven't replaced. Okay? So here, I'm saying lim x approaches 3. Here, this is a difference of 2 squares, so I'll write x minus 3, okay? X plus 3 over x minus 3, okay? So here, so long as x minus 3 is not equal to 0, I can cancel here so that I have lim of x approaches 3, okay, is this and that can go, then this becomes x plus 3. Now I have a similar problem as, to this, where I'll just do the direct substitution thing. So I'll say this is lim, so I'll just say, where there's x here, I'll put a 3, so I'll say 3 plus what? 3, so that I get a what? A 6. Hence I'll write the limiting value of x squared minus 9 over x minus 3 as x approaches 3 is equal to what? 6. Okay, so those are the necessary steps that we need. Okay, so from there on now, I'll introduce coordinate geometry and the idea of the gradient of a straight line as well as the gradient of a curve at a particular point. Now, for me to introduce the gradient of a curve, I'll start with the gradient of a straight line at a particular point. Okay? So, coordinate geometry, that's a gradient of a straight line. And please take note, do not forget this part, all these parts, because I'm going to combine them into one concept. Okay, so the gradient of a straight line between 2 points. The gradient of a straight line between 2 points. Remember, under coordinate geometry, we place points on a Cartesian plane. So for our start, we shall deal with the x or y plane, where we only have 2 coordinates. We have the x coordinate and the y coordinate, where we know that the first coordinate is the x coordinate and the second one is the y coordinate, where we read this as x comma y. So if I have a Cartesian plane where I have y there, x there, okay, then I have a straight line here. This is point A, this is point B, and point A there is x1 comma y1, and at point B we have x2 comma y2. That is, okay, this is x2, this is, okay, y2, then this is x1, that is y1. Okay, now what we know is here, from the distance from here to there, okay, the distance from here to there, we shall say modulus of that, which is y2 minus y1. Okay, so that is the distance from here to there is y2 minus y1. That is change in y. Okay, then here, this side, what we know is from here to there, that's change in x. So change in x is what? x2 minus x1. Now the gradient of a straight line, the gradient of a straight line AB is equal to change in y over change in x. Okay? So that the gradient of a straight line AB is equal to, what is the change in y? Is y2 minus y1 over x2 minus x1. Okay? So just to make that clear, I'm going to give you an example. Okay? Calculate the gradient of a straight line given that the line passes through the points A 2,3, B 6,5. Okay, so we have 2 points there. We have A 2,3 and we have B 6,5. Okay, so the choice, it depends on you. You can call this your x1, this your y1, this your x2, this your y2, or you can call this your x1, y1, x2, y2. You still get the same answer. So we know that gradient is given by change in y over change in x. That is y2 minus y1 over x2 minus x1. So my y2 here is 5 minus my y1 is 3 over my x2 is 6, my x1 2. So I'm going to get 5 minus 3, that's 2, 6 minus 2, that's 4. So here I'm getting half. So that the gradient of a straight line passing through the points A and B is half. Okay? So we have an idea of the gradient of a straight line. We know that the gradient of a straight line is constant. It is the same at each and every point along that same straight line. Now, what about the gradient of a curve? Okay, so the gradient of a curve changes at each and every point. Okay, and calculus is the mathematics of change. So if you want to measure anything that has to do with change, just know that you have to use calculus. Okay, if it's motion, so long as there's a change of position, change of this time, change of displacement, change of velocity, change of acceleration, just so that you have to use calculus in those terms. Okay, so here, gradient of a curve. Gradient of a curve. Okay, now I'm told that we've been told in class we are given the equation of a curve or the equation of a straight line as a function. Okay, so for example, you can be given a function y is equal to f of x. Okay, now you can graph this function. Assume we have this function and we've graphed it. The function looks something like this. Okay, assume it's just this function is this, y is equal to f of x. Okay, that's the function defining this curve here. Okay, we do not know what this curve is. We are just talking about general terms. Okay, what we know is we can pick a point on this particular curve. Let's call this point P. Okay, at this point P, we know the coordinate here is what? X. Okay, we know this is the x coordinate. Okay, and that is the y coordinate. At this particular point here, the y coordinate here will be what? Will be y. Let me call this. Okay, so this will be y. Is there a problem there? I know there's no problem. And we know that this y here, it is what? F of x. Okay? So, at this particular point, the value of y depends on the value of x because we are saying y is a function of x. So, if we have the x here, it means that y here is what? Is f of x. So, at point P, the coordinates are x, comma, f of x. Okay? X, comma, f of x. So we have a point P there. Okay? We can also choose a point Q away from what? From x. Okay? So let's choose this point. Let this point be Q. Now, this point Q is h units away from what? From P. H units away from P. So the distance between P and Q, the distance between P and Q is what? H. Okay? The distance between P and Q is what? H. Okay? So if this is x and I've moved h units in front of me, I'm suspecting that at this point I'll be at x plus h. Okay? So at this point I'll be what? At x plus h. Okay? So here I'm saying if x is x, okay? Here we have a rule which is saying y is equal to f of x. Y is a function of x, okay? So my input here is x. So if my input is x, the output is what? F of x, okay? Now, what if my input is x plus h here? It means that my output will be what? F of x plus h, because my input is x plus h. Okay, remember the notation when I say f of x, this simply means what is the output when the input is what? X, okay? So if I write f of x plus h, it means that what is the what? What is the output when the input is x plus h? Okay, so if the input is x plus h, I'm suspecting that at this point, the output will be what? F of x plus h. So this is y1, that is y2. Okay, so I'm suspecting that at this point I'm going to have x plus h, okay, as the x coordinate. Then the y coordinate will be the function of x plus h. Okay, the output when the input is x plus h. Okay, assuming there's no problem there. Okay, now we know that the gradient of a curve changes at each and every point, but we can just get an approximate value of the gradient between of the gradient at point P by estimating with the gradient of the line PQ. So we can draw a line, and this line that cuts a curve at 2 points is known as a secant. Okay, so we can estimate the gradient of the curve at point P by using a secant that passes through the point P. Okay, we know that the gradient of because this is a straight line, so we apply the formula for the gradient of a straight line. So the gradient of the secant line PQ is equal to change in y, okay, over change in x. And change in y, that is y2 minus y1 over x2 minus x1. Okay, now my y2 here, take note, my y2 here, it is what? It is the output when the input is x plus h. Okay, so the input here is x plus h, my output is what? X plus h, f of x plus h. So that my y2 is what? F of x plus h minus my y1 here, my y1, which is what? My y1 is simply a function of x because the input here is x, so that my output is what? F of x. Okay, so over my x2 is x plus h, okay, that is x plus h, minus my x1 here, it is x, okay, so that when I evaluate this, it becomes f of x plus h minus f of x over, know that x and the negative x can go, so that we have something like this. And remember, I introduced something like this there, which I called the quotient difference, okay? So from there on now, we know that this is just an approximate value. Okay, so how can we get the exact value? One thing we know is it is possible at this point we cannot choose this point, we can choose a point closer to P. It can be this point, okay? Or we can move, we can come here, or we can move, we can come here, we can move, we can come here, we can move, we can continue moving, eventually we'll arrive at point what? Point P. Now, I want you to realize one thing. As you are moving, closer to P, this distance h here is depleting, it is approaching a value of 0. Okay, so the idea here is what will be the limit? The value here at this point of this function will be the limit of that function as this distance here approaches a 0. Okay, so that the exact gradient at this point P will be, the gradient at point P will be the limiting value of f of x plus h minus f of x over h as h approaches 0. Okay? Now, this gradient at that point, because we're talking about algebra here, we're talking in general terms, and that gradient is what we call the f prime of x. Okay? So f prime of x just simply means find the gradient function. So whatever we're going to get here is a gradient function. So that f prime of x is equal to lim h approaches 0, f of x plus h minus f of x over h. And this is an important formula which they call working from the first principles of calculus. The first principle, some instructors call it the delta method. The delta method. Okay, so don't be lost when an instructor says use the delta method, just use the first principle, it's the same thing. Okay, so this is the first principle of differential calculus, and we shall use it to calculate the derivative. This f prime of x is also known as the derivative. Okay, this f prime of x is also known as the differential coefficient. So sometimes you have to understand all these terms. Okay, one instructor might prefer one type of what? Technical term to use. Okay, so I'll give an example. Using the first principle, okay, using the first principle, calculate the derivative of x squared. Okay, now for us to calculate the derivative of x squared, let's say the derivative of x squared, we can write, we know the formula to use because we are taught to use the first principle. It is f prime of x, so this is f of x is equal to x squared. It is f prime of x, take the limiting value of the function f of x plus h minus f of x over h as h approaches 0. Okay, now we have the knowledge of a function. When I say x, the f of x plus h, it means that my input is x plus h. It means there must be a rule. The rule is what we've been given, x squared. If you have your input as x, just square the input. Okay, that's the rule. So it means that f prime of x, remember, take the limiting value all the way until you make the substitution. Limiting value of h approaches 0. Here, the input is not x, but it is x plus h. But according to the rule, it is saying square the input, x squared. So whatever the input, square it. So our input here is x plus h. So I'm going to do what? Square the input. Okay? Minus, here my input is what? X. So what am I going to do? The rule is saying square the input. So I'm going to square the input over what? Over h. So that here I'm going to have f prime of x is equal to, take the limiting value, h approaches 0, x plus h squared minus x squared over h. Oh, wait, sir, what are you doing? Can't we just do the direct substitution here where we say where there's h we put 0? Yes, we can do that, but take note of this. If I say 0 plus, if I say x plus 0 squared minus x squared over 0, I'm going to have something like x squared minus x squared over 0. I'm going to have 0 over 0, and that is the taboo that we were talking about. So what are we going to do? Algebra comes our way. Okay, so this is f prime of x is equal to, take the limiting value as h approaches 0. So I'm going to expand this, please. This is not x squared plus h squared. No, expand this using binomial theorem, or you can use Pascal's triangle, which I know you did at your first year. So this is x squared plus 2x h plus h squared minus this here, x squared over h. So the whole lot of this expression is just this x plus h squared. Okay? So from there now, we have lim h approaches 0, like terms together. The x squared and this negative x squared can go, so that we only have 2xh plus h squared over h. And please, people of God, do not be tempted to cancel something like this. You don't do that, okay? So the first thing what you know is you need to take out the h because you're dealing with the h. Factor out the h on top so that you have something like this. So I'm talking in the language of algebra here. So you factor out h. So if you have forgotten your grade 8 algebra, go back. So this is 2x plus h over h. Now, because there is multiplication here, and please, if you see an addition sign separating the two terms or a minus sign, do not cancel here. You can only cancel if you see a multiplication. Okay? So you go with that and that, so that we have lim h approaches 0, 2x plus h. Okay? So here now we can do the direct substitution and forget the lim. So where there's h there, I'll put a what? A 0. So I would say 2x plus 0. I'm going to have a 2x. So that f prime of x is equal to what? 2x. That is the derivative or the differential coefficient of x squared is 2x. Okay? And since here, when deriving the first principle, we are using the idea of a gradient. It means that if you are given to calculate the gradient of a curve at the point where x is 3, just plug in this formula that we've got in the f prime of x, because this is a what? A gradient function. Okay? So if we want to calculate the gradient at point P where x is 3, just put 3 here, it will be 2 times 3, so that we have a gradient of 6. I hope there's no problem there. Okay, so for mathematics, we shall end there.